Okay, this is Leetcode 55, a jump game. So you're given an integer array nums. You are initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. So we're tasked with returning true if you can reach the last index, or false otherwise. So using this test case here, where nums is 2, 3, 1, 1, and 4, the output ends up being true. And as we go through this, you can see that this takes a free type structure, and we can easily verify if the solution is true. We run a n squared dynamic programming slash recursion type solution. But as you can see, based on this tree structure, there's a ton of repeated work. As we get to the same indexes, we're basically going to recalculate everything again. So if we get to index 2 with a value of 1, we're always going to follow the same path down the tree. So the biggest thing to take from this is not that we need to somehow memorize the dynamic programming solution, but we can actually be greedy here, and we can, as we traverse through this array, we can capture what is going to be the total mass that we can possibly reach from each position. And this takes a completely different uh, this allows us to take a completely different approach than the dynamic programming solution, and allows us to do this in O of n time complexity, which is obviously way more efficient. So as we get into the code here, all we're going to do is we're going to have one value that tracks basically each position, how far is the maximum possible jump that we can have. And we're going to keep this running. And at each point, we'll either decrease or we'll add the max specific position. So we'll have the maximum jump length total as a variable, and we'll initialize that to an integer. And we'll initialize that to 0 at the start because we're not going to be able to jump anywhere in the case that there's 0 as the only value in the array. And we'll just loop through, and we're going to enumerate through. So we'll say for I num in enumerate nums, because we'll need to know the index of where we are in the array. And at this point, what we're going to do is we're going to take the of maximum jump length -1. And the -1 is important because at each point, we're going to be moving one step over. So we're actually going to be subtracting from the maximum jump length. And we'll compare that to whatever num is. So whatever the value of the jump is at the current point. Next, all we're going to need to do is we're going to need to is maximum jump length 0? So if it equals 0, or sorry, and nums, so the length of nums -1 does not equal, because if we're at the end, like I brought up earlier, and there's just the single value in the array, we are technically already at the end. So we're just verifying that we're not at the end, because if it's 0 at the end, we're still at the end of the array and we'll still return true. But if it's 0 at the -1th index, then we know we can't get to the end of the array. So at this point, we know we can return false. And if we make it all the way, we know we can return true. We run that successful, and we finish it up. There you go.